Hello and welcome to Advent of Code in F# day 5. Now, before we get to the today's puzzle, I wanted to share something interesting I found on Twitter. Thomas Petricek, one of the famous names in F#, yeah, he's been working with F# for a while now. He's doing Advent of Code in F# as well, but he's code golfing, so he's trying to write the smallest program possible to solve the problem. And this is his, for example, this is his solution to day 4, part 1. So yesterday, the passport validation thing, it fits in a tweet. So I thought that was interesting. He's also like parsing the text, filtering the valid ones. But the thing I found interesting is when he's checking for whether every required property is in there, he's using sets and is subset of. I found it interesting. I'm gonna remember that for the future. So if you want to see Advent of Code puzzle solved in the tweet for as long as it's possible, take a look at Thomas's Twitter. But anyhow, let's go to day 5, binary boarding. We board our plane only to discover a new problem. Dropped our boarding pass. We aren't sure which sheet is ours, and all of the flight attendants are busy. So of course we write a quick program to use our phone's camera to scan all of the boarding passes. Instead of zones or groups, these airlines use binary space partitioning. Oh, we're going to binary search our way to our seat. Seat is specified like where F means front, B means back, L left. Okay, so we're doing a two-dimensional binary search. First 7 characters will be front or back. 7, yeah, that's 128 rows, which tells you which half of a region the given seat is in. Yeah, so it's every step divides the search space in half. We have the whole list of rows. First letter indicates whether the seat is in the front or the back. And front is the first half of the indexes, back is the second half. And so on it goes. Okay, there's an example, so I think we're gonna start with that one. If we have this string, we first encounter an F, so we have to take the first half of the rows. Yeah, B means take the last half of the rows that remain. Yep. And we end up with, yeah, with seven inputs, we always end up with one digit or one number, sorry, if we start with 128 rows. Yep, and you have to do the same thing for the columns with left or right. There are 8 columns, yeah. So those are 3 characters. Yeah, makes sense. And then this means that we decode one of these inputs to a row and a column. Yeah, it's 2 numbers, and then we have to do something like multiply them again. We multiply the row by 8 and add the column to have a magical number we can give to the website. And we have some examples to verify our code. Cool. Okay, so our input is not a single boarding pass, our input is a list of boarding passes. What is the highest seat ID on a boarding pass? Okay, so we have to calculate the seat ID for every boarding pass in our input and find the highest one. That's a whole lot of boarding passes again. So let's take them. We're day 5. I'm gonna quickly. Oh, that's not what I want to do. There we go. So I want to quickly make a new folder for day 5. Let's forget about part 2 for now. I'll keep the file, but there. Where's my boarding pass list? Why is copy paste not working? Oh dear God. I don't know why, but copy paste is saying is not having it today. So let's try another way. Maybe Visual Studio Code wants to copy paste. No. Oh dear God. Open up, please. Thank you. Okay, so it's a Visual Studio thing. It's not a Chrome thing. I'm gonna quickly reboot my Visual Studio. In the meantime, let's think about how we will solve this. So every row is one of these codes, and we have to loop over it from left to right. We always start with like the whole search space, and every step we divide the search space in half, either the rows or the columns. So I am thinking of using a fold here. So we used an unfold a couple days ago to generate like a sequence of states. Now we have to go the other way around. We have a sequence of inputs, and we want to thread some computation through that. So I think a fold is well suited for that. Why is this input file still empty? I don't know what's happening. Hello, computer. Okay. We don't need regular expressions today. Okay. Are we good? Hello. Okay, we are good. Yeah, so let's first just take one of the examples. Yeah, the work that example, and let's try to emulate this one. Yeah. Hi. So yeah, let's fold through it. And if we look at the type signature for a fold, it needs a folder function, which takes a state and an element of the list and returns a new state. And it also takes an initial state and returns, and a list as input, where we will fold over, and it returns the final state, like the state after we visit the last element in the list. What's a state? Well, we're trying to search a two-dimensional space. So if you look at the examples, we're keeping track of, okay, we're in this is the minimum index of the row and the maximum, so I think we just need 2 pairs to keep track of this. Does it make sense to use a pair? Should we just use, yeah, let's just use 2 pairs. So to make it explicit, I'm going to build something called state, and row, we only have to update one of the properties, so I'm gonna go do it like this. So we have a minimum row, maximum row, minimum column, and a maximum column. And it always trips me up, like type declarations need a semicolon, but when you use it in code, like the instances, the objects, you have to use a column, a comma. I think it trips me up. No, you don't have to use a comma. I don't know why it keeps tripping me up then, but I miss it every time. So let's write this fold. I'm gonna call the step function step, and we'll deal with that later. But the initial state, that's easy. It's from 0 to 127. and the columns was from 0 to 7, like 8 options. So this is our initial state, and our step. What comes first, the state or the element? The state. And are we gonna parse? No. The options are this simple. Let's not explicitly parse the input strings. Let's just work on strings and characters for now. So this is a, let's call this take step. I'm not using refactoring tools because it crashed my Visual Studio yesterday. And what we get is one of those commands or steps. What's it called? A character? Just a character? Yeah, let's use the word character. So this doesn't do anything. This will fold over the entire list and give us the initial state, but now our type signatures line up, so we know we only have to implement this function to make it work. It's a little in-between step I always take. Now I'm second guessing my type definition, or the way I structured the data, because we always have to take, like, you have to figure out what's half of. Yeah, we'll stick with it. So let's first figure out what we're seeing. If it's F, we do something front, back, left, right, front, back, left, right, and whatever. Again, I'm gonna break out of it if we don't match correctly, because it's a puzzle and throwing fatal exceptions is not the end of the world here. So if we get an F, a front, this means we have to take the first half of the search space, of the row search space. So first half, how do we do that? We calculate the length of the space, the search space, we divide it by 2, and we offset that with the minimum. Yeah. So is average the correct word? Yeah. Let's not use average, let's use mid. Row max minus row min. Is that what we're trying to do? Let's put the example next to it. So if we start at the start, F means take the lower half, which means take the first. So we need to calculate 63. So that is take 127, subtract 0, and divide that by 2, which is 63.5, and then round down. So if we divide 127 by 2, we get 63. So we just can use integer division. So if we do the first half, we are updating row max. So let's update row max with row max is, and that is that just the 63? So yeah, and that is actually row min, so the first offset. Is this correct? Is this the way to do it? Or can we just like do 127 minus? We could do that, but I think this is going to be easier. So row min plus mid, basically. And it does not know what I'm talking about because they are behind the state. And we're going to be typing state a lot. Should I abbreviate it? No, we should not. Let's keep it explicit. I'm gonna leave the other ones out and just play around with the taking a step F to make sure that it's working. So let's write some tests. So take a step. I'm gonna write a helper function as well to create states. It's faster than using the record syntax all the time. For tests, for example, if I can just focus on the data and not get lost in the structure, that helps me. So let's make a factory function. So this makes states, and in our test now we can just like make states from 0 to 127, from 0 to 7, like the search space we're using in the example. And we also need a character, and we have just implemented a verb, and that should return a new state. Yeah, and let's just say compare that with a new state. But if we do the step front, we take the first half of the rows. This should be our 63. This should be what we expect. I know character input. Huh? I'm not parsing anything, right? Confused. Oh yeah, I'm already folding over here. Sorry. There we go. So this is no, it's not correct. Interesting. What's it saying? So this is what gets calculated. It's not doing anything. It's not returning a new state. Interesting. Let's start the debug. So for example, this is what we're working with, and I'm just gonna reassign that to a variable called state in the REPL. You can refer to whatever you just did as it. Let's say like file it is this. If you now say file state is it, now the variable state is assigned to this. So now you can like play around with it in the REPL. For example, this line of code is referencing state. Well, now it's using the state I just assigned it to. What? Oh yeah. Mid is not mid. Mid is the size of our search vector. Mid is divide this by 2. Oh my god. So let's just divide this by 2. I can't believe we missed this one. This will work better. Let's see. That's better. Yeah, no output is good output. I'm just gonna wrap it with some string printing so I can immediately see that we have failing tests. Print footnote for new line. There we go. So whenever we encounter a string test done without any problems, we know we're good. Anywho, I'm glad we did this now and not in 10 minutes, because then we would have duplicated this thinking error 4 times. For back, let's test drive this. For back, it means take the second half. So that means, no, let's take a back example from the actual example, because there is one in here, and it's even the next step. So we can work on this state. the state, and when we then go back, we need to keep the second half. So again, what's the midpoint between 63 and 0, which is 31.5, and then we take 32. Ah, interesting. Yeah. So our rounding errors get taken into account. 32 through 63. So now we're updating the back half. So again, we still need. Now I'm thinking, is integer division what we need? We start from 127 and then we start dividing by 2. Maybe that's not even a problem to keep it like it is. But we're updating row min. And do we need +1 here? And is that +1 always valid? That's a bit what I'm concerned about right now. So let's see what we have. Now we are expecting to be 3263. And it's saying I am 3163. So for this specific example, just noodling on a +1 would do it. But is this like something that's universally true? Is this an invariant? I'm not sure. Oh, sorry. I have another bug. Yeah, we have another bug, so we have to. Well, what am I doing here? So row max, row min. Oh yeah. This is not correct. You don't have to add the original row min. We just have to. Okay. Now I'm getting confused. Let's stop and think about this. If we have something like from 0 to 63 and we take the back half, do we need to work with the 0? Yes, to define the midpoint, but the midpoint is all we need, except the off by 1 thing. Yeah, this is better. It's not better according to the REPL. No, it's not better according to the REPL. What's wrong? Because I haven't provided the correct assertion. 32 to 63, that is correct. Ah, there's a 40 in there. This is a +1. I don't think it's gonna keep working. Let's step through the example. Let's step through the entire example, yeah. So again, an F on this result. So let's take this result and thread an F through it to keep the front half of the rows. So it's 32 to 47. That works, but now the interesting one. So again, the last half, the back. So it should be 40 to 47. 40 to 47. When we do another back, 40. So I'm thinking this will not work, and that +1 hack is what literally what it is, a hack. Yeah. That's not even the problem. The problem is worse. The problem is worse. So what are we reading here? If we have a search space of 32 through 47, and we take the back half, so somewhere the midpoint should be 40. Yeah, take 8 steps. Take 8 steps. So yes, we do have to move on from this 32. We can just ignore it. So this was not the way to go. So this should be state dot row min plus whatever, and we'll figure out the -1 in a second. What? Is everything okay? Everything is correct. I am actually surprised by that. Okay. I keep hitting enter to make sure, but it doesn't change the results. Okay, so these are front to back, and for this one single example, it seems to work. Let's do the last two. So B should keep 44 to 47. B should keep 44 through 47. It does. And F should keep through 45. (44 through 45) F. It does. And the final F keeps the lower up to 44. So there's another F. 45, and it keeps the lower, which is 44. It does. So the BF parsing, I think we're done. Now left right, it should be the exact same thing, but on the column space, where L means the minimum and R means take the final, the upper half, they call it. So this is the upper half bit, and that should go when we see right. So let's move right up. Yeah, let's move right up. It's gonna be, or yeah, no, we need to do something different. I thought same logic, we can reuse this, but we're storing it in, or we're checking different properties of that state, so it's not row max but col max. Same thinking applies for everything else, I think. Yep, and left is exactly this bit, but on column space. Column space. Let's just do. Okay, now I'm not gonna rerun. I'm just gonna rerun an entire example. I'm not just gonna run the take a step. So let's make a function of the what we're doing here. So this take a step with an initial state. Let's call this evaluate or search. Search. It does not like. The search has been referred to as generic type. Okay, it doesn't like not knowing it takes a string. So it's something that takes a string and returns a state. No. So this is our algorithm, the search function. No, we have to load in the everything, also the new RL parsing. Okay, let's test those examples out before we go into the input. So decoding this entire string should reveal 44.5. Decoding this entire string with search, and search is a bad name because they call it decode, and that should return exactly row 44 column 5. So that should be 44 44 5 5. Yeah, I renamed it. REPL does know, and that seems to work. No, that does not seem to work. Interesting. 44. Coleman 2-2, 44-44, 2-2, that is not what we would like to see. So are we mixing up left and right? Yeah, before I start thinking, I'm gonna mix. No, let's start thinking. Let's do the step-by-step thing. We're bound to see the problem. So R should take 4-7. If we do an R starting from this state, an R starting from this state should go 4-7. Yeah, so it should be 4-7. I think we have our bug already. We do. So we're not taking 4-7, we're taking 0-3. So we're literally swapped the two searches around. Good going. Would we have caught this by thinking a bit better? Yes. Am I not awake enough to think better? Exactly. So sometimes tests help me out for this as well. Is this what we're expecting? Yes. And now we can parse an entire thing. Yeah. Okay, we did one. There's some more examples, but let's first try it on our input, which I hope is still in the text file. It is. So that is our input. It's in there. It's in there. So let's run our decode for every line. This input we shouldn't need a single string. We should read the lines. Yeah, and then we can map over it and decode every string. See if that works already. It does. And then we have to calculate the seed ID, which is multiply row by 8, add the column. Okay. Let's just do it in line. State. I'm thinking, should this decode return our internal structure? Let's not. So let's have this return an actual coordinate on the grid. So yeah. So we have a state calculated up here if we provide this the text, and then we return coordinate or our pair with row min and row max are the same, yeah. Column, row, column. So it would take a string and we return a pair, yeah, that makes sense. So this should be 44-5, right? Yeah, still works. So now we have a row column, and it's row times 8 plus column, if I'm not mistaken. Yeah. What's the problem? What's the problem? So if you do decode, oh yeah, it's a list of decoded things, not a single one. So let's just thread result of our decode to the seed ID calculation. There we go. Now we have our seed IDs and the highest seed ID. So let's take the max. That's our highest seed ID. And that's correct. So let's just move on to part 2. Just done part 2 in here. Let's see what we have to do. First, coffee. Ding! Fasten seatbelt signs have turned on. Time to find our seat. Flight is completely full, so your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on the aircraft. So they will be missing from our list as well. Wait, what? We have to find our seat, and we have a highest seat ID. Or we know all the seat IDs of the boarding passes. Ah, okay. The seat should be the missing boarding pass in our list. So we have a sequence of numbers now, and we're missing something. What's the catch? That some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list. Does this mean we have to like find the minimum and the maximum in the list of seat IDs? I know, the seats with IDs +1 and -1 from yours will be in your list. Okay, so I think if you find like the minimum seat ID in the list and the maximum, and we just iterate over everything in between, one of those will not be in the list of seat IDs, and that's ours. So we need all the seat IDs, and that's what we have here. How many do we have actually? I don't care. Let's thread through the entire search space. So that is from min to max. And what do? We try to find the first, so then we loop over it and we look it up, for example. Will that work? Yeah, and we see the first, we look for the first number that doesn't appear in the seat IDs. So let's generate a sequence of all the numbers we have to look at, and that is seat IDs min for 2 seat IDs max. What am I doing? Come on. So this generates a sequence of all the numbers between the lowest encountered seat ID and the highest. What is the highest actually? So we're going from 32 to 848, which was our part 1. Yeah. So now we're looping over every seat ID or every hypothetical seat ID, and one of those is not in there. So we're trying to find the first one that's not in there. Can we use the set trick from Thomas we saw in the tweet? So one set of all the numbers and another set of one number less. If we subtract, that will work. Do we have set subtraction in F#? So this is the set of all seat IDs. And what can we do with a set? Subtract difference, yeah. So if we do the difference of all with the set of given seat IDs, we should have a singleton set. And it does appear we have a singleton set. And it does appear that is our seat ID. So I'm on a plane. Hope you enjoyed today's Advent of Code in F#, and I'll see you tomorrow.